All right, everybody, today we are working with exponents. So anytime you have something like 3 squared or n to the negative 7th power, this year you're even going to see things like 16 raised to the 2/3. Those exponents can even be fractions. That is kind of what we're dealing with today. Couple of things to keep in mind. First of all, the number at the bottom, that's called the base. The number at the top, that's what we call the exponent, all right? Now, you have a bunch of little formulas, a bunch of properties, a bunch of rules in your notes, and they all are written using variables like a and m and n. So pause the video really quick, and off to the side, I also wrote down a version of it with numbers. So pause the video, copy those down, and then hit play. We'll go over each one. So 0 exponent. A to the 0 equals 1. What that means is anytime you raise a number to the 0 power, your answer becomes 1. So 19 to the 0 is equal to 1. The product rule. Any number raised to a power multiplied by that same number raised to a power, you just add the powers together. So 3 to the 7th times 3 to the 8th, you just add the 7 and the 8 together and you get 3 to the 15th. Quotient rule, if you have a to the m divided by a to the n, they cancel each other out. So over here to the left, 6 to the 7th divided by 6 squared is just 6 to the 5th because the 2 on the bottom cancel out. Or if it's the other way around, 6 squared on top, 6 to the 7th on the bottom, you end up with 1 over 6 to the 5th because the 2 on the top cancel out. Negative exponent. This is one of my favorite exponent rules because it's very powerful. We don't like negative exponents, and it's really easy to get rid of them. All you have to do is move it up or move it down a fraction bar. So right here we have 6 to the negative 2. I don't want negative 2. I want positive 2. So all I do is move it to the bottom. Or if the negative's on the bottom, 1 over 7 to the negative 6, I just move it to the top, and now it's a positive. So wherever it's at, you can move it, get rid of it, nice and easy, okay? Couple more examples for you to pause and write down. The power rule. If I have an exponent being raised to another exponent, if I'm exponenting an exponent, then I multiply them together. 5 cubed raised to the 7th, I do the 3 times 7, and I end up with 5 to the 21. Power of a product. If you have two numbers on the inside being multiplied and an exponent on the outside, you can kind of distribute that n, that number on the outside, that exponent, to everything on the inside. So 3x on the inside to the 3rd power becomes 3 cubed x cubed. And then the last one, it works the same way. If you have numbers on the inside being divided and an exponent on the outside, the exponent distributes to everything on the inside, okay? Now, I would love to tell you that that's what you're going to see on your math test, right? Oh, hey, this is all you need to know for your math homework. That's not the case. In fact, these rules by themselves, especially with calculators, aren't really all that powerful. If someone said, hey, Mr. Reed, what's 3 to the 7th times 3 to the 8th? I'm not going to sit down and say, oh, well, that's 3 to the 15th. I'm just going to type 3 to the 7th times 3 to the 8th in my calculator. Where these rules become really powerful is when we have big, complicated equations. And believe it or not, in the real world, most of the time, the equations that you're having to deal with aren't nice, easy equations. They're usually pretty messy to start. So our examples, that's what we've got. We've got a bunch of messy expressions that we need to simplify. We want to clean them up and make them look pretty, all right? So our first ugly expression, number 1, x to the 6th power times y cubed times x to the 4th. Now notice on all of these examples, there is no adding and there is no subtracting. And that's because these rules don't work if you've got pluses and minuses mixed in there. This only works when everything's being multiplied or divided, okay? So my properties up above tell me that I've got x to the 6th and x to the 4th. Since they both have an x on the bottom, I can just add the 6 and the 4 together and I get x to the 10th. And the y to the third, there's no other y's, so that just stays y to the third power, and I'm done, all right? So yes, it's still not really pretty, but it looks better than it did when we started. Number 2, 4x cubed and 5x to the 6th. Again, no adding, no subtracting, so we can use these properties to clean things up a little bit. First thing I'm going to do, I've got a 4 and a 5 that are being multiplied. Well, I know what that is. 4 times 5, that's just 20. Now I've got an x cubed and an x to the 6th. Since they both have an x on the bottom, that becomes x to the 9th power. I just add the 3 and the 6 together. So my answer becomes 20x to the 9th. All right, number 3. 3a to the 5th, b to the 7th, c. All of that is being raised to the 4th power. So usually I look at the inside first and make sure there's nothing I can clean up inside the parentheses. Simplifying is kind of like solving, and back in 6th and 7th grade, you learned the order of operations, right? PEMDAS or GEMDAS. You have to do inside the parentheses first. Kind of the same thing with simplifying. On this one, there's really nothing I can do on the inside. Nothing can combine, nothing reduces, just nothing happens inside. So next I look at the exponent on the outside. And the rules up above tell me I have to distribute that to everything on the inside. All right. So what that does is when I distribute it to the 3, that becomes 3 to the 4th power. Now when I distribute it to the a's, well, I already have a to the 5th. Now I am distributing another exponent. And remember up above, if you exponent an exponent, you multiply them. So when I distribute that 4 to the a, it becomes a to the 20th. When I distribute it to the b, I do 4 times 7, which is what, 28? And when I distribute it to the c, even though you don't see an exponent with the c, there's actually a 1 there. And 1 times 4, well, that's just 4. So 3 to the 4th, a to the 20th, b to the 28th, c to the 4th. Now, I'm going to clean this up one more step because 3 to the 4th, I have a calculator. I'm all technologically advanced, right? That's a big word. 3 to the 4th, that's just 81. Type that in, figure out what it is, simplify as much as you can, right? So 81, a to the 20th, b to the 28th, c to the 4th. And that's where I would stop because I can't do any more. So number 4, we're finally getting some division going on here. I've got a 6x to the 4th on top and an 18x to the 10th on the bottom. Still no plus, no minus, so I can use these rules. Well, first thing I'm going to do, go back to elementary school, 6 over 18. Well, maybe 6th grade, right? That reduces. They both divide by 6, don't they? So that reduces to 1 over 3. So I got rid of my 6 and my 18. Now I've got x to the 4th and x to the 10th. And I told you before that some of those are going to cancel out. So what happens is I've got 4 x's on top, right? And I've got 10 x's on the bottom. Hopefully I can count. Well, they cancel each other out because things are being multiplied. Those cancel, those cancel, those cancel, those cancel. And so all of my x's on top go away. There's no more x's, but I've got 6 left over on the bottom. So my answer becomes 1 over 3x to the 6th power. All right, number 5. 2n to the 7th divided by 3n squared, all raised to the 3rd power. So I'm going to, well, there's a few different ways I can do this. When I look at that parenthesis, before I deal with this exponent out here, I can simplify the inside. I've got n's on the top and n's on the bottom. I've got 7 on top, 2 on the bottom. So those are going to cancel out, and I'm going to get 5 left over on top, and the ones on the bottom go away. So now I just have a 2 on top, a 3 on the bottom, and that 3 still on the outside. That cleaned it up a little bit. Now I can deal with the exponent, which our rules above tell me have to distribute to everything on the inside, right? So I end up with 2 to the 3rd power. The n to the 5th gets raised to the 3rd, so that becomes n to the 15th. And on the bottom, I get 3 to the third. And I can clean this up a little bit. Nothing cancels on the top and bottom, but 2 to the third, I know that that's 8. If you don't know that that's 8, type it in your calculator, figure out that it's 8. On the bottom, 3 to the third, I know that's 27. If you don't, type it in, figure out what it is. 8 n to the 15th over 27. Now, a lot of people that I've worked with in the past would distribute that 3 first. They would distribute the 3 to everything, and there's nothing wrong with that. You end up with the same answer. Just really quick, that becomes 2 to the third, n to the 21 over 3 to the third, n to the 6th. Now when I cancel my n's right here, look what I end up with. 2 to the third, n to the 15th over 3 to the third, which matches what I had above. So it doesn't matter if you distribute the exponent first or second, you end up with the same answer. But if I can get rid of that inside, if I can simplify it a little bit at the beginning, I'm going to try to, all right? Number 6, my favorite problem on the homework. Well, on the examples, there's a lot better ones on the back. X squared times y, all of that is being raised to the negative 2. And then on the bottom, I've got 2x y being raised to the negative 3. There's a couple of different ways that you can do this. First thing I'm going to do for this example, I'm going to take that negative 2 and I'm going to distribute it to everything on the inside. Okay, so x squared, when I raise that to the negative 2, that becomes x to the negative 4 because 2 times negative 2 is negative 4. Y raised to the negative 2 is just y raised to the negative 2. And then on the bottom, I have a 2, an x, and a y to the negative 3. Now, I told you earlier, we don't like negative exponents. We really don't. They're messy. We don't really know what to do with them mathematically. So we are going to change them all to positive. And I'm going to do that. I'm going to take them, and I'm going to move them up or move them down. This x to the negative 4th, I'm going to move down. The y to the negative 2 is going to get moved to the bottom, and the y to the negative 3 is going to get moved up. Notice that negative 3 on bottom is only connected to the y. So on top, all I've got is y to the third because I moved it up. The x to the negative 4 moved down. So now I have an x to the positive 4, and I have a 2, and I have a normal x, and then I also moved that y to the negative 2 to the bottom, and it became y to the positive 2. So I should have made my fraction bar a lot bigger, right? So I've got a lot going on the bottom. Let's kind of clean it up a little bit. I've got 3 y's on top, 2 y's on the bottom right here. So my rules tell me that those cancel out, and I'm going to have 1 left over on the top. So I'm going to have a y left over on top. On the bottom, x to the 4th and x, those have the same base. Remember, this is kind of like x to the 1. So that becomes x to the 5th power. And then I've got this 2 just kind of hanging out all by itself. Now, usually I'll put the 2 out in front, so I would write y over 2 times x to the 5th, and that would be my final answer. Okay, on the homework, you are going to see a lot of messy looking expressions. Start with the rules that you know. Look inside the parentheses, simplify what you can, distribute stuff from outside. Follow these steps. We're going to work on them in class for the most part. So I'll answer questions and I can help you out when you get stuck. Good luck.